Hello all, welcome back to our classes on civil engineering project management. Today we'll be discussing about a very important topic, material management. These are the contents covered in the syllabus, and as you all know, for any project, material management plays a very crucial role because if a project, many of the projects, they suffer or sometimes fail because of improperly managed materials, and as you all know, that can lead to loss of profit or economy, or sometimes it will lead to slipping of time schedule, or missing the milestones in delivery or completion, or sometimes that can lead to some environmental impacts and so on, various issues. Now here we will be looking at this material management in a very limited scope, because it's such a vast subject, and we'll not be looking at the costing part of this and monitoring or tracking part of this material management. That's a that has to be covered separately. That's not coming under the purview of the syllabus. And also for some complex scenarios, we'll have to apply some mathematical techniques and other processes, like some linear programming techniques are applied for solving resource allocation issues, and then sometimes the challenge will be to minimize the transportation cost and maximize the contributions, and then we'll have to work on that, and then on these optimization techniques will be used here. And then sometimes supply chain management, that is a topic which comes under this, and that's not covered here, so we'll be seeing only that limited scope. And I'm not explaining here that for any project it's all about attaining specific identified objectives by performing both engineering and managerial functions over the resources. And when it comes to the management of engineering projects, say for any project, there is something called 7M concepts, like man, material, money, methods, mother nature, materials, everything, and this management is applied over all these 6 M's. So altogether it is considered as 7 M's, and these are what we see here. I'm sorry, there was one chart which was representation of managerial function, which is missing in this. I'll try to fix that problem in a separate PPT. Now all that managerial functions, such as planning, scheduling, controlling, coordinating, monitoring, etc., are applied to each of these resources. Say for labor or man, staff, we need to apply all the managerial functions, that planning for this material management, man, and then scheduling the labor tasks and other their contracts and all, we have to schedule it, and then we have to plan and monitor all that. And same thing applies to the machinery, and then money, that I think we'll be covering in that budget and financial planning and all. Then methods and techniques, that again is with the project managers, construction managers, and then everything in a sustainable manner. So that is by mother nature. And then materials, yes, of course, this is the most important component of this resource, because this is what is transformed into that constructed facility, because all other things are applied, but this is what we see physically, this material. And material management concepts, they refer to all the purchased items that are utilized in a project site, such as construction material for permanent works and temporary works, bulk raw material, finishing material, electrical, mechanical. You can read and understand this. And one thing we have to keep in mind is we may be civil engineers, but when it comes to a project, it is not just the civil engineering materials and civil engineering tasks. Other electrical and mechanical HVAC, heating, ventilation and air conditioning and other firefighting, and so many other tasks will come into this. So we have to, for our project means it's inclusive of all types of works. And then material management involves operational materials required for operational and maintenance works, and then supporting of plant equipment spares, that small spare parts required for this are coming under this. And then materials account for almost 40% of the project cost. And efficient material management, they call for integrated approach covering numerous functions such as material planning, purchase, inventory control, storekeeping, warehousing, and then handling and transportation, codification, standardization, etc. are applied over the are required for the efficient material management. Now, and we'll look at this in detail, and it is one of the critical component of the construction industry, assuring right material in the right place, in the right quantity, at the right time. And if anything goes wrong, then the whole project will be, entire thing will be upset. And a properly implemented material management program, they can achieve a proper improved work phase planning, increase labor productivity, and better schedules and lower project cost. So everything will be reflected in the project performance. If any of the if there is any, that's what, if there are certain parameters, key parameters. If you look at the if you look at those key parameters, we'll be able to understand the performance of the project. And objectives of material management are cost control, you can read this, okay? I'm not taking time of this, and these are the various and these are the various factors based on which we'll be classifying the material, like storage space, because there are some concepts like there are different approaches in this material management. Like there is a Japanese philosophy of doing everything. I think you might have heard about it. Just in time, JIT. Just in time means they don't have this inventory spaces, storing spaces and all. Whatever. So they don't. They will start doing the work only after receiving the order. So therefore, there is no such warehousing, or there is no such material storing. They don't require a storage place, basically, because they have everything in raw material form, and as they receive the intent or order, then they will work on it. And so therefore there is no requirement for a storage space at all. Whereas there are some philosophies where it is about storing everything, all the finished finalized goods stored in a place. So that will require more space, as well as it will consume other that will consume more resources and all. So then shelf life means for some material shelf life will be very short, for some it will be very long. Say in cement there are some criteria which should not be used if the cement is if it is it is stored for a beyond certain period of time, it is not supposed to be used. So that is one thing. And for rebar and all, we'll have to apply some non-corrosive coatings and all, otherwise it will get corroded. And whereas for some other material, like our basic building blocks and all, that will have more life. And then supply reliability, this is one important thing. Suppose we need to get materials from some foreign, from some, we have to get some export material and all, say in such cases there is a reliability, in the sense sometimes there will be some shipping problems, or due to some any reasons this project may suffer because of that. So therefore this is very important, like confidence in receiving the materials on time. Then inventory cost, for us to store and warehouse any material, then that also will consume cost. So we need to find a break even for this, or we need to understand what is a benefit cost analysis of having an inventory for a particular project or material, and then construction sequence, in which order we perform this, and then transportation requirement. Because in some projects will be at a very remote place where we cannot the transportation will be a very big challenge. So in such cases, the only option would be, or the better option would be to set up some inventory and storage places. Whereas if the same project takes place in a near the city where there is much access, then sometimes we'll be able to save that storage place. That's it. Now price, and then procurement time and sources and project life, etc. Then so there are various factors which are to be considered for this. And even when a company when a contractor they quote for a tender, and they'll be taking some time to study about the project, right? So then this is one of the important thing which they study, like availability of raw materials and their their proximity to some of the quarry sources, or other things, accessibility, and so many issues. These are of prime concern, and this actually this influences the rate which they quote. Now the inventory and inventory control means it can be defined as which ensures the supply of required quantity and quantity of inventory at the required time, and at the same time it prevents unnecessary investment in inventories. Inventories are the physical stock of items that an organization keeps in hand for efficient running of activities. You can read that. I think I'm skipping all this. You can understand this. Inventory cost means the cost of purchase of material. Okay, we need to place an order, right? So for that purchasing, that requires some effort, and that requires you have to put in some resources to for this purchase activity, and that cost is called as a purchase cost. And then you have order cost. I think order cost is the see when we purchase some material, I think there is some cost. I think we'll see that in detail later. Okay. Then inventory and inventory control. The benefits of inventory control are like it ensures an adequate supply of materials, and it minimizes inventory cost, facilitate purchasing economics, etc. You can read this. And then inventory control, one of the techniques of inventory control is ABC inventory control technique is based on, it is called as ABC analysis or ABC inventory control, and this technique is based on the principle of a principle that a small portion of the items may typically represent the bulk of money value of the total inventory in construction process, while a relatively large number of items may form a small part of the money value of stores. Which means out of 100 items, a small portion, say some 20 items or 15 items or 30 items, that will be constituting the larger portion of the cost. Okay. Whereas the remaining huge bulk will be constituting only a small portion of the cost. So something like the cause and effect, I think we'll see in detail later. And the money value is ascertained by multiplying the quantity of material of each item by its unit rate, that you all know. And the relative position of these items, they show that items of category A should be this. I think you'll understand only if you see the table. And here ABC approach states that that a company should rate items from A to C, A, B, C, and category A corresponds to 5% to 10%, or this percentage limit can vary, of the item, which represent about 70 to 75% of the money value. Similarly, B item means 15 to 20% percentage of the total item for a project, but and that constitute approximately the same percentage of money, whereas C items are those which constitute much larger percentage, but larger proportion, but at the same time it represents only a small fraction of the total cost. Now if you, and suppose we classify these materials, then like this, okay, graphically we can represent like this, a graph where x-axis represent number of items and y-axis total value of rupees. Say in take it in rupees, category 10 percentage items, okay, 10, only for 10 number of items, 10 pieces, it is 70 rupees. Then for second category is 20 pieces and 20 rupees, and the remaining is like 10, 20, 30, okay, 30 and 70 pieces and 10 rupee, like that. That's a proportion. Now you can read this characteristics of each of these items. Item A means these items have some major proportions: purchase cost, purchase value, and the capital should not be blocked in these cases. But these are the those identified items which are very less in quantity, but which has more which is more expensive, or which which is contributing to the which has more purchase value, you can say. So such items must be given higher priority, and we should be ensuring that the capital we should give more weightage to that, you can say, and it can be ordered frequently and consumed immediately, and they require special attention in stores. And items B means, as we said, you can read this carefully. I'm sure you will understand. And there is another similar principle or approach called as Pareto principle, or Pareto's 80-20 rule, where here in this ABC analysis we are categorizing them into A, B, C, 3 parts, whereas Pareto or 80-20 rule is that it says for many events about roughly 80% of the effects come from 20% of causes, and in vice versa, 20% of effects come from 80% of causes, like that. Now this is another way of classifying. We can adopt this Pareto principle also, if not going for that ABC analysis, and then grouping category into ABC items. So these are the the criteria based on which we categorize them, like bulky or bulky and one-time purchase, repetitive, and the minor materials. Then vital, essential, and desirable materials. Then indigenous and imported material, because what is locally available and what is to be imported. So this is one category. And then high price, medium price, and low price. Based on the price, we can categorize them. And even the same I think we can give some specific examples also, like first of all, what we see is in this category we'll try to see that which is more cost effective, and we'll be giving more importance and emphasis for that. And when it comes to the risk assessment and all, and this is a very important part of that, availability of materials and anything related to the material, this is also part of the risk assessment. Now high usage, based on the usage also you can classify them, like high usage, medium usage, etc. I think see, for equipment, construction equipment and all, some of the equipments will be of very high usage, whereas some materials will be some equipment will be used only for some specific tasks. So in such cases, when we have this category, it will help us to make some managerial decision of buying or renting, that we have seen in that equipment topic. And then use of ABC analysis for developing policy guidelines. So these are the various policy considerations, like degree of control required. For A category requires strict control, whereas B category moderate, and C is loose because it's available in plenty. And then safety stock, because in some items we need to have a very high. For category A, we cannot afford to have more safety stock. Okay, like we must be ready to go for the purchase as and when required. Whereas for B items, we can have a moderate one, and C items, there is no, it's not expensive, so we can get that small items and store it, because even procuring that will be even more expensive than having the inventory, having it in inventory. Now, the steps for the classification of ABC items, or there are some steps and procedures which can be followed to perform this ABC classification or categorization, called as ABC analysis. One is identify the materials required and estimate the quantity of each material, then obtain an approximate unit rate of the item. See, suppose we have a project, and suppose we get a BOQ, right? And when we have the tender document, another thing what we do is, contractors, they will try to identify the various construction materials required, and they will try to get from the QS, they will try to get approximate quantity of each of this material, because in BOQ it provides line items. Say BOQ will be getting something like a concrete M30 concrete, M25 concrete, but concrete involves materials like aggregates and chemicals and other things, right? So therefore, if you want to get specifically, so here what we do is we identify each material, like cement. Of the total cost, cement constitutes certain amount, and aggregate, coarse and fine aggregate constitute certain amount, reinforcement constitutes certain amount. Like that, we get material wise details, and then obtain the approximate unit rate of each item. That by some means we'll get the approximate rate, and then assess the requirement during the period under construction, and yearly or project completion basis. If it is a very short project, then we'll go for the whole project, whereas if it is for a very long project, then we'll take it on annual basis, and then determine the usage value of each type by multiplying the quantity required with the corresponding unit rate. So when you multiply the quantity with the rate, you will get the total amount for each of the material, and calculate the percentage usage value of each material with respect to the total project. So again, I'm saying the total project means it is not covering the cost of labor and other things. It is only representing the cost of the material. Okay, as we said, if that constitute only 40%, so then out of that 40%, what percentage is consumed by each of the materials. So that sort of percentage allocation will identify this exercise, okay, through this exercise, and then arrange these items. And after doing that, say cement constitute 19% of the total material cost, then some other material, tiles or blocks or bricks, which constitute about 10%, 15% or 20% of the total cost, something like that. So after this, then we will arrange the items in a descending order, from highest to lowest order of usage, and then consider the materials in the descending order of usage value, and then compute the cumulative value. And next we compute the cumulative value of these, and finally the final will be the 100% of the total material cost, which may be approximately 40% of the total project. And now what we do is we draw two horizontal lines demarcating the whole materials into two parts. One will be drawn at 20%, and another one will be drawn at 80%. Now, or in other words, I think since we are coming in the descending order, we'll be starting with the highest, the material with highest price, right? So therefore, we'll be first drawing a line, and which demarcates a few number of items which constitute major portion of the total material cost. Say 70% of the cost are grouped in the by the first demarcation line, and then after some some position, then we'll be drawing another line which will demarcate the materials into this category B and C, like that. And it is to be noted that ABC grouping is based on estimated consumption cost of materials over a selected period, and ABC and B refers to the items that are ranked and the remaining items are C. I think you can read this. And the construction material for any project wastage planning, okay, there is something called allowed and unavoidable wastage, allowed wastage or unavoidable wastage in a project. For each of the material in a project, there will be definitely certain amount which will go as losses or wastage, and if it goes beyond that, then that is that will not be considered as acceptable, and that that will question the quality of work. And for cement, approximately allowable wastage is 2%, for sand some 10%, and then rebar 3%. For projects and all, what we do is, we after the near the completion of the project, as the project is nearing completion, then an exercise called reconciliation will be done by the QS and other project team, and they'll try to see how much material is ordered, and then how much material is utilized or put into work, and then that difference is actually the losses, and that they have to clearly identify. And in steel, rebar and all, if anything goes beyond that 2.5 to 3%, then that's a that will have cost impact on one hand, because when you quote the tender, you'll be quoting it by considering all the wastages. But if that goes to some 5% or 4%, then that small percentage will have a serious cost impact, which and the project team is answerable for that. And I'll try to give you more details about this this wastage and all, because this rebar wastage, that itself has got some 3 classification, something like one is the visible wastage, reusable wastage, then another one is scrap or non-reusable wastage, and another one is invisible wastage. There are 3 category. One is there are some small pieces of relatively large pieces of rebar which can be reused in some other places, that is reusable kind of wastage. And there is another category of small pieces which cannot be reused anywhere, and that will go as waste or scrap, so that is not reusable waste. And another category is completely invisible, because that will be small small cuttings and all, which you'll not be able to identify also. So such okay, then we'll discuss in detail. Then main causes of controllable wastages, advantages, disadvantages. I think my battery is getting low down, and please go through these limitations, and we'll take up this economic order quantity in the next video.